Welcome back to the third tutorial of Real Numbers Chapter 1. Before jumping to the exercise 1.3, let us know some theorems that we are using in that exercise. So the first theorem is 1.3. So what does this theorem says? Let x be a rational number whose decimal expansion terminates. Means the decimal number should not end with a bar. It should not end with a bar. It should not have a continuous number. It should terminate, means it should end at one point. Then x can be expressed in the form of p by q, means in the form of a rational number as p by q. This number should be expressed in the form of p by q. When we remove this point here, we get 1, 2, 3 zeros as 10 power 3. So it can be expressed in the form of p by q, where p and q are co-primes. So what are co-primes? Co-primes are nothing but prime numbers. Those numbers that have only one common factor. For example, we have a number 9, though it is not a prime number, it is a co-prime. How? It has only one common factor, that is 3 3s are 9. Apart from 1 and itself, it has one number that can make the product as 9. So it is a co-prime. It is similar to the prime number. Moving on. And the prime factorization of q is in the form of 2 power n and 5 power m, where n and m are non-negative integers. So we should always turn the denominator in the form of 2 power n and 5 power m. So what's n here is 3. We can write 10 as 2 into 5. 2 into 5 whole power 3 means 2 power 3, 5 power 3. Moving on to theorem 1.4. It is similar to the theorem 1.3, where x is expressed in the form of p by q, that is rational number, as we have said before, such that the prime factorization of q is in the form of 2 power n and 5 power m. Just as before, 2 power, we should open this number, the q part, into the form of 2 or 5. Even anyone is acceptable. So we cannot have 5 here. So we are just taking as 2 power n as 2 power 2. That's it. So the difference is it doesn't have any co-prime in the explanation, where it does have in the theorem 1.3 it has co-primes, where in theorem 1.4 there are no co-primes. But we don't have to worry about that. Those two theorems are nothing but kind of 90% similar to each other. So where n and m are non-negative integers, then x has decimal expansion that terminates, as it is said that these decimal expansion 3 should terminate. It should not continuous as, let me show you that, 3.1212 something like that, 12 bar. So this is a non-terminating form of any, it's just a random example that I gave, where 3 is terminating as it doesn't have point and goes on with a bar. So non-terminating, just as the previous theorem, it is also non-terminating. So decimal form of 3 by 4 is 0.75. As it terminates at 75, it doesn't goes on. Similarly, we have another theorem, that is 1.5. So this theorem is complete opposite of the previous one, where the factors of q should not be in the form of 2 power n and 5 power m. Means this is the one that has continuous non-terminating decimal form, where in the previous we have q as terminating decimal form. Here q is non-terminating decimal form. See, as it says that where n and m are non-negative integers, then it has a decimal which is non-terminating, repeating, recurring, whatever you want to say. These three things have same meaning, means it should repeat. As 1.3 cannot be terminate, let me give you an example how it is done. We take 3 and take 1. 1 doesn't come in 3 table. Let's take 0 and a point. So what comes here if we take 0 here? It's 10, right? When we take a point, we add a 0 here. 3 3s are 9. Again 1 remaining, as we already have a point. Let's take one more 0. 3 3s are 9. Again 1 remaining, as you already have point, we take 0 and it goes on. So it goes on. This thing is known as non-terminating continuous decimal form. So theorem 1.5 is the one which has non-terminating, where theorem 1.3 and 4 are the one with terminating. So let's jump to the exercise 1.3. Exercise 1.3. So the first question is, write the following rational number in their decimal forms and also state which are terminating and which are non-terminating repeating decimals. So we got the difference, right? Which are terminating and which are non-terminating. Let me just repeat it once. Terminating are the one which ends without any bar or continuous decimal. Non-terminating and repeating are the one which doesn't end, which cannot end, right? So what's the first question we have? 3 by 8. So how are you going to find? Just as I have shown you before, the division form. Let's take 8 as a quotient. 3 doesn't come in 8. Let's take a point and add a 0 here. So 8 3s are 24. 30 minus 24 remaining 6. When we have a point, let's add a 0. We can add as many zeros we want once we have a point. 60. So does 60 come in 8 table? Nuh-uh. 7 8s are 56. 56 comes as 7. 8 into 7 is 56. Again 60 minus 56. 4 remaining. You already have point here. Let's add 0. 8 5s are 40. 40 minus 40, 0. It ends at 375. When we got 0, it ends. So there is no continuation. So the result is a terminating decimal. See, denominator is in the form of 8 is equals to 2 cube. Means, I'll just show you how it is. This 8, 3 by 8. This 8 can be written as 3 by 2 into 2 into 2, which can be written as 3 by 2 cube. It is in the form of 2 power n, right? We need two things, that is 2 power n or 5 power m, any of these or both. So we got 2 power n as 2 cube. So denominator is in the form of 2 cube, consists of only 2's, hence a terminating decimal, right? And the decimal form is 0.375. Let's go to the next one. Here's the next question, second one. 229 by 400. 400 cannot be divided 2 to 9 because 2 to 9 is small. Let's take a point and add 0. Similarly, how we have done in the previous example, 400 into 5 is 2000. When we subtract, we get 2900. Again, 400 into 7 is 2800. When we subtract, we get 1000. Then 400 into 2 is 800. We got answer as remaining 200. Then again we can add 0 as it is. Then 400 into 5 is 2000. 2000 minus 2000, we got 0, and it terminates at 5725. Exactly how it's terminated before. Now we need to do the factors of 400 in the form of 2's and 5, right? So how can we write the factors of 400? 2 power 4 and 2 power 5. If we elaborate it, 2 into 2 into 2 into 2 into 5 into 5, we get the answer 400. So it is in the form of 2 power n and 5 power m. It is a terminating decimal. So the decimal value is 0.5725. Okay. Now, next question. Third one. We have a mixed fraction here in the third question, right? So first we need to convert a mixed fraction into an improper fraction. After that, we need to do the division form. So how are we going to do that? We have learned this in the previous classes, how we are going to convert a mixed fraction. We need to multiply these two things. Then we need to add the result with the numerator. That is the form of converting mixed fraction into improper fraction. So 4 into 5 is equals to 20. Result is 20 plus, what's the numerator we have? 1 whole by the 5 remains as it is as a denominator. 5, which is equals to 21 by 5. That's it. We got the answer as 21 by 5 here. Now let's start the division. We need to divide 21 with 5. 5 fours are 20. It comes, so we don't need to take any point or 0 and add extra 0 here because 5 is already a small number which can divide 21. Remaining is 1. Now we need a point. 1 cannot come in 5 table, so we'll apply point here and add a 0. 5 twos are 10. 0. We got the decimal form as 4.2 and it terminates just as previous ones. Denominator is 5. A terminating decimal. See, the denominator is 5, which is in the form of 2 power n and 5 power m, right? We need any one. So we got 5 power m, which is as 5. If there is nothing, that is 1, right? So 5 power m. The 4 into 1.5 can be written as 4.2 in a decimal form, and it is in the form of 5 power m, so it is a terminating decimal with the decimal 4.2. Let's next move to the next question. Fourth one is 2 by 11. Let's take 11 and divide 2. As usual, 2 is smaller, which cannot be divided by 11, so let's take a 0 and a point and take 20. 11 into 1, 11. 20 minus 11 is 9. We have point already. Let's add a 0. 11 into 8, 88. 90 minus 88 is 2. We have point. Add 0 again. 11 into 1, 11. Again we got 9. The same thing is repeating, right? So we got a recurring, repeating and non-terminating number here. Recurring, repeating, non-terminating. So what is it? The denominator is not in the form of 2 power n and 5 power m. Hence a non-terminating repeating decimal, as 11 have no factors. It is a prime numbers. It doesn't come in 2. It neither come in 5. None of those can apply to the denominator 11. So the decimal is also not in the form of 2 power n and 5 power m, as well as the denominator is also a non-terminating decimal which goes on as 18, 18, 18 and so on with the 18 bar. So it is a non-terminating decimal number. Next question is, without performing division, state whether the following rational numbers will have terminating decimal form or non-terminating. It's the same question as the first one, but in the first question we did perform division, right? We divide this numerator with the denominator, but in this question he is asking us not to divide, okay, without performing. So how can we do that? Let's take an LCM. We just need the factors, right? We can do with any method, either by prime factorization method or with the use of LCM or with the use of division. So as it is telling us not to perform division, we'll use an LCM here. So let's take 3125 and take the LCM. While taking the LCM, do that, we need to take the smallest number here, which can divide this number. So 2, 3 and 4 doesn't divide this number. So the next smallest number is 5, as it ends with 5. Whenever a number is ends with 5 or 0, we should take 5 as the divisor. 5, 6, 30. 31 minus 30, 1 remaining. Then 5 2s are 10. 12 minus 10 is 2 remaining. Then here is also 2 remaining. 5 5s are 25. Then again take 5. 5 1s are 5. 6 minus 5 is 1. 1 remaining here, which is invisible. 5 2s are 10. 10 here. 12 minus 10 is again 2 remaining. Then it's 25. 5 5s are 25. Then 5 into 25 is 125. Then 5 into 5 is 25. Then 5 into 1 is the answer. So what's the decimal expansion we got here is 5 into 5 into 5 into 5 into 5. How many 5 we have? 1, 2, 3, 4, 5, which is in the form of 5 power 5. Yes, it is in the form of 5 power m. The denominator is in the form of 2 power n and 5 power m. It is a terminating decimal. Next question. 64 by 455. Let's open 455. Again, ends with 5, so we need to take 5. 5 nines are 45 as it is. 5 ones are 5. Now, does 91 come in 5 table? No. Nearest smallest number is 7. 91 comes in 7 table. 7 into 13 is equals to 91. 13 is also a prime number, so directly 13 ones are 13. So what are the factors we got of 455 is 5, 7 and 13. Is it in the form of 2 power n and 5 power m? No. It is not in the form of 2 power n and 5 power m. So it is a non-terminating decimal, which is 5 into 7 into 15. 64 by 545 is a non-terminating repeating decimal. Moving 23 by 3 cube and 5 square. Just by looking at the question, we can say it is exactly in the form of 2 power n and 5 power m, right? The denominator is in the form of 2 power n, 5 power m, therefore it is a terminating decimal. Nothing to solve there. The next is 7th one. Here we have the denominator as 2 square, 5 power 7 and 7 power 5. We got one extra, that is 7 power 5, and we cannot even cancel it as 7 power 5 and 129. These two cannot cancel, so non-terminating answer even if you try to cancel it. So it is not in the form of power n and 5 power m, so it is a non-terminating decimal. Next, write the following rational number in the decimal form using theorem 1.4. So what was the theorem 1.4? Just as how we have solved the questions, we need to convert these terms, the denominator in the form of 2 power n and 5 power m with the prime numbers, and where q should not equals to the 0. So how can we write as 2 into 5 is 10, 10 power n. So we can write either as 10 power n or 2 power n or 5 power m. 13 by 25. So we can open 25 as 5 into 5, which is 5 square. But we also need 2 power n because we need as 10, right? If we have 5 here, so to make it 10, what do we need? To make it 10, we need 2. So multiply and divide, 2 square, because we have 5 square, 2 square, 2 square. 13 into 2 square is 4, 5 square as it is, 2 square. So 5 to the 10, 10 square is 100. 13 into 4 is 52 by 100. As when we convert this into decimal, we have 2 zeros here, so we need to add point before two numbers. I'll show you just 52 by 100. The number of zeros we are removing to convert it into a decimal, that many numbers before we need to add point. 1 0 1 number, 2 0 2 number, so we need to add point here. As there is nothing here, then we can write 0 as 0.52. That is the answer, 0.52. Next question, 23 by 2 cube and 5 square. So we need equal numbers here to make it in the form of 10, right? If we don't have the same number of powers, then we cannot direct multiply as 10. So we need one more 5, multiply and divide by 5. We got 23 into 5 is 115. 2 cube into 5 cube, 10 cube equals to 1000, right? If we remove these 3 zeros, so we need to add point before 3 numbers, 1 2 3, which make it as 0.115. Fourth question, that is we have 3 square and 5 square, 7218. Now 3 square can be written as 9, 5 square as it is. Let's cancel these out with the 9. So 9 ones are 9 and 9 eights are 72. We take two numbers directly, so we need to add 0 in the middle. 9 twos are 18. We got 802. Now 5 square as it is 5 square. What do we need? We need 2 square. Again multiply and divide by 2 square with this. 802 into 2 square, 5 square into 2 square, 802 into 4, 2 square is 4, then 5 into 2 is 10, that is 10 square. Then when we multiply 802 into 4, we get 3208 by 10 square. We have two zeros here as 10 square. So after two numbers, that is 8 and 0, so we need to put the point here. That is 32.08 as a decimal form. Last question of the exercise is 143 by 110. Again, 110 can open as 22 into 5. Then 120 into 5 can open as 2 into 5 into 11, right? As 22 can open as 2 into 11 is 22. 5 as it is 143 by. Now we will cut out this 11 as 11 here first, because we need to cut 11 ones 11, right? So 14 minus 11 is 3, 11 3 is 33, so we got 13 by 2 into 5 is 10. So how many zeros we have? 1 0 after one number, which is equals to 1.3. Here we got the decimal form as 1.3. Fourth question is, express the following decimal in the form of p by q and write the prime factors of q. And we should also say what do we observe, means whether it is terminating, non-terminating, is it rational or not. Everything, whatever we observe, we need to say that, specify it in our answer. Let's take the given number as 43.123, 43.123, write it in p by q form. So we need to remove this point. How many numbers we have? 1 2 3, which we'll add 3 zeros here. 43123 by 1000, it is in the form of p by q. We need to factorize the denominators as 10 cube. We got it as 2 into 5 whole cube is 10 cube. Then 2 cube into 5 cube, which is in the form of 2 power n and 5 power m, right? Denominator is in the form of 2 power n and 5 power m. So it is a terminating decimal, and as well as it is in the form of p by q with the factors q. We know that it is a rational number. Next question. 0.120112000, so on, it's going on as 2001 2001. So it is a continuous division, which means it is a non-terminating decimal. Only just by looking at it, we can say that it is a non-terminating decimal, and we cannot even factorize it as p by q, so it is not a rational number as well. Now, third question is 43.12, the given number. Let us consider this number as x. Okay, 43.12, and so on. Given in the equation as 43.12 bar. So it is a non-terminating continuous number. So let's consider this number as x, 43.12, so on. Multiply 100 on both sides. X into 100 is 100x. Then 100 into 43.12, so on. So we are adding two zeros, right? Let's move forward two numbers. When we are dividing with the two zeros, let me just write. If we have 43 by 100, we are moving back two numbers. If we are dividing 43 into 100, sorry, multiplying 43 into 100, then we are moving forward two numbers. So now we are multiplying 100 on the both sides, so we need to move forward two numbers, that is 4312.1212, so on. Let's consider this as equation 1 and this as equation 2. 2 minus 1. Now 100x minus x is 99x. 4312.1212, so on, minus 43.1212. is 4269. Now let's take this 99 into the denominator as it is in the multiplication here. So when we take it to the is equals to side, opposite side of the is equals to, it goes in the division. X is equals to 4269 by 99. Let's cut it out with the 3 table. 3 3s are 9, 3 3s are 9. I'll just show you. 3 3s are 9, 3 3s are 9. Now 3 1s are 3. 1 remaining. 3 4s are 12. Then 3 2s are 6. 3 3s are 9, which comes as 1423 by 33. Now, denominator is not in the form of 2 power n and 5 power m, because 5 and 2 doesn't come in 33. 33 has no factors of 5 and 2, so it is a non-terminating repeating decimal, which is already given in the question as non-terminating repeating decimal. But q can have prime factors other than 2 and 5, means 33 can be written as, I'll just show you with an example. So we can write 33 as 11 into 3, right? 2 prime factors which making a composite number. So what was the explanation of the rational number? It is in the form of p by q, where q is in the form of sum of 2 prime numbers, right? So these are 2 prime numbers. So but q can have prime factors other than 2 and 5, so it is a rational number. Though it is not a terminating repeating decimal, it is a rational number. Sometimes we get these questions that we will say just by looking at the question, oh, it is terminating, so it is not a rational number and it is a non-terminating decimal form. But we need to check the denominator first. If the denominator satisfies the rational number form as p by q, where q is not equal to 0 and has prime factors, then it is a rational number. So 0.63, given number is 0.63. Let x is equal to 0.6363 as the bar is given already in the question. So multiply 100 similarly as we did in the previous question. 100x we are multiplying, so let's jump this point 2 numbers ahead. 63.63, second minus 1. 100x minus x is 99x. Then 63.6363 minus 0.6363 is equals to 63. Now bring this 99 which is in the multiplication to the division form. X is equals to 63 by 99. Let's cancel it out as 3 3s are 9, 3 3s are 9, 3 2s are 6, 3 1s are 3 as 21 by 3. We can cancel again as 3 1s are 3, 3 1s are 3, 3 7s are 21, which is equals to 7 by 11. Denominator is not in the form of 2 power n and 2 power m, so it is non-terminating repeating decimal, as well as 11 doesn't also have any factors, just as in the previous question where 33 has the factors. But here we don't have 11 as the factors. We have 33 factors, but 11 doesn't have any factors apart from 2 and 5. So it is not a rational number. So we are done with today's exercise. I hope you understand everything. Thank you.